Now we're going to look at slightly more complicated proofs that lines are parallel. So in this example, I'm going to use the given information, which is that measure of angle 1 is congruent to a measure of angle 5, to prove that two lines are parallel. And I also need to provide the name of the postulate or theorem that supports my answer. So first of all, I'll go ahead and mark the two angles. And it's a good idea to mark the line that touches both angles at the same time. That's your transversal. Then mark the other lines that are also creating the angle, and those will be your parallel lines. So I can definitely say that angle E is congruent to angle G if angle 1 is congruent to angle 5. Why? Well, angle 1 and angle 5, you can see they're on the same side of the transversal, and they're both on the left of the parallel line, so they are corresponding angles. So the reason I can say the lines are parallel, remember to prove lines are parallel, we use the converse. So it's the converse of the corresponding angle postulate. For the second example, we're saying that the measure of angle 7 plus the measure of angle 10 is 180. So I'm just going to go ahead and mark both of these angles. I'm not trying to say they're congruent, I just want to see where they are. Then I'm going to mark the line that runs along both of the angles. That's our transversal. Then mark the two lines that make the angle with the transversal. That would be lines E and F. So those are going to be my two lines that could be parallel. Are they? Well, 7 and 10 are supplementary. And if you look at it, they're on the same side of the transversal, and they're on the outside of those two lines. So yes, I can say E is parallel to F by the converse of the same side exterior angle theorem. Now we're also going to take a look at two-column proof. So the last ones that we were doing were pretty much single-step proof. I just had to give you one theorem or postulate. So here I'm going to have to do multiple steps. And that's for multiple steps, we typically use a two-column proof. It's a great way to organize. The first column is going to be your statement, and the second column will be the justification, which would be like the angle, theorem, or definition. The first statements made are usually out of the given for the problem. So you just write given on the justification. Now, if you don't know the name of a theorem or a postulate, try to write a sentence or something explaining, well, this is always true. For example, if I said angle A is 90 degrees and you wanted to say angle A is a right angle, you could say all right angles are 90 degrees, or all 90-degree angles are right angles. So let's take a look at this proof. I want to prove that line P is parallel to line R, and I'm given that lines L and M are already parallel, and that angle 1 is congruent to angle 3. So you can see my first statement here. L is parallel to M. That's a given. Angle 1 is congruent to angle 3. By the way, it's a really great idea to mark your congruences on your diagram if you have one for your proof. And that's also a given. Now I can say, since these two lines are parallel, angle 1 is also congruent to angle 2. Why is that? Well, they're corresponding angles. And the corresponding angle postulate says if the lines are parallel, corresponding angles are congruent. Now you can see I have the same congruent mark on all three angles. That means angle 2 is also congruent to angle 3. Sort of like a substitution. It's a transitive property of congruence. So if you wanted to, if you didn't know transitive property of congruence, you could say, well, it's kind of like substitution. You're substituting in angle 2 for angle 1 on this beginning one. Now I can conclude, that the two lines are parallel. Why can I do that? Well, you can see here, let me go ahead and mark my highlighter. Here is the transversal for, I'm trying to prove that P and R are parallel. So I don't want P or R to be highlighted. M is my transversal. I have angle 2 and angle 3 are congruent, and they are alternate exterior angles. So to prove something's parallel, remember we use the converse. In this case, I'm using the converse of the alternate exterior angle theorem. So for further reflection, What does it mean when something is given in a problem? Well, essentially that means that you can take it as true. What are the two components of a two-column proof? Well, one is your statement, and the other is your justification or the reason that you can make that statement. And why do you think the theorems proving lines parallel have the word converse in their name? Well, I'll give you a hint. I'll start with the corresponding angle postulate. If two lines are parallel, then the corresponding angles are congruent. So let me do the converse. If the corresponding angles are congruent, then the lines are parallel.